Hello, welcome to another episode of the Cool Tools Show and Tell. Our special guest this week is Robert Stencel. And Robert, would you like to introduce yourself to our viewers and listeners?
Sure. Well, I gather we're contemporaries, so you may remember something as ancient as the Sputnik event. Our friends, the Russians, basically challenged us in the States to meet or exceed, and that led me into a STEM career involving astrophysics research and some years as a NASA staffer as well. However, currently I'm a retired professor of astronomy from U of Denver, and there I managed two observatories, one from the 1890s, a real classic, as well as a very high altitude at 14,000 plus feet, which is where we first became acquainted, essentially, when Wired covered a bit of a windstorm we had there.
Wow. Well, great. Well, thank you so much. I know you have some tools for us that you'd like to share. Some may be astronomical, some may not. Could you tell us about your first tool that you would like to share?
Well, I mentioned the Sputnik event some decades ago. In that time, I've really been involved in telescopes professionally for that whole period. And part of the development, of course, parallels the advance in computers from microcomputers to Raspberry Pi and everything in between. And kind of the culmination du jour of all this is a fine little product called Unistellar's eVscope, illustrated here. Among the beauties of it, it's a backpackable telescope. So you can maybe see the outline of the backpack. It's about 25 pounds of weight, but it's a very smart telescope in the sense that with a phone app, seen there on the upper right, you can basically direct it to assorted stars, constellations, planets, etc. This has really taken the educational world by storm because, of course, every student comes equipped with a phone, and to run a scope themselves is a real treat. And so it's a great way to engage. The origin of this briefly.
So let me slow down a little bit here. I want to again to describe this for those who may be listening. It's this is a telescope that is about, you say it can be put into a backpack?
Right, it's backpackable. They designed it specifically carrying
it's about the size of, I don't know, 18 inches or so?
Yeah, a printer kind of scale to it. Mm-hmm.
Right, and so with and this is a one that's an optical telescope that you would have a little eyepiece, and so the kids or anybody would go up and look at it, but it has to be on a tripod as well?
For stability, yes.
Right,
it's not handheld in that respect. It's your standard telescope tube featuring a mirror, bounces light back to an eyepiece, which also doubles as a digital eyepiece, can capture images on command. And it does rest on a tripod, and incredibly portable but smart, because it's also sensing GPS location, ties into the time, and through the app, using their planetarium app, allows the user to go anywhere in the sky.
Right, and so the kids are looking at the images not on their phones, but actually in the eyepiece. The phone is just used to steer it and orient it. Is that right?
Steer and capture. Capture. Yes, visually in the eyepiece, as well as you can share that image to the phone and snap.
All right. And what's the magnification of the telescope?
Well, it's not super high. And magnification is just one of many parameters, but it's good enough to show you the rings of Saturn, the moons of Jupiter, nebulae clusters. For introductory level, being so portable and so user-friendly, it's really fabulous. And may I add the origin story? Way back in the 70s, a clever guy named Tom Melsheimer realized that these computers could then begin to talk to devices like this to steer them successfully. And so years he worked with an earlier telescope provider to enable these go-to style telescopes. That is usually through a screen and keyboard back then, but that really revolutionized access to the sky for a lot of people, including me.
Okay, and how much does it cost?
Well, it'll set you back about $2,000 at this point.
Well,
But as it takes off, this is a relatively new product. I bet the pricing will come down over time.
okay. So, so Robert, what's your second tool that you have to share with us?
Right. It's a very delightful planetarium app that'll run on computers as well as phones these days. And it's known as Stellarium at stellarium.com. That is the website. It's very versatile, all kinds of platforms from Mac and Windows to Linux and phones, as mentioned, Android and other. And the beauty of it is it will give you an all-sky presentation as well as allowing you to zoom in. So as a planetarium-like platform, I find it incredibly handy to look at past and future events as well as current sky, dial in on where is Mars tonight and what side of Mars will we be looking at. So again, in conjunction with the eVscope, that first tool, it's a great way to get ready for an evening's observing session.
Okay. You say a planetarium app. I'm not really sure what that means. Is this one, does this mean, is this like a stargazing app?
Right. Hopefully you've been to a planetarium once or twice.
Right.
Essentially, it's what drives the projector at those facilities. Same idea that you've got a full star map in there with a lot of ability to wrap and unwrap maps, zoom and scroll and distort as needed to represent particular aspects.
But most people don't have a planetarium, so I'm not sure what a planetarium app mean. What does that mean?
Well, it's representing the sky on your flat screen, whatever it is. You don't actually need a curved dome for this, and so maybe it's
so
not the best adjective.
I've seen stargazing apps where I can put up my phone up to the sky and
Bingo.
showing me what the star, identifying the stars up there and the constellations as they move around. Is that what this is, or is this
same idea? Same idea, order of magnitude more complete, with all kinds of detail your phone app probably doesn't contain. So for someone using the eVscope for planning purposes, I want to find that particular star cluster, may or may not be illustrated on your other phone app. Stellarium will give you that kind of detail as well as satellites and a diversity of other features. It's amazing. I recommend it.
So give me some more of the benefits of this over a stargazing app. You mostly use it in conjunction with the telescope. Is that the idea?
Yes. It can be used on a desktop or laptop screen. Less convenient than a phone, perhaps, but it also gives you that depth of information that probably can't be accommodated on most phones at present.
Well,
I haven't tried Stellarium on an iPhone, for example.
What's an example of the depth of information?
So there may be individual stars in individual clusters or individual satellites coming by, and Stellarium will disclose all that information if you zoom in on it, basically. I don't know if your phone app illustrates what satellite is going by, for example.
Okay.
So if the ISS is going by, Stellarium will illustrate that. Chinese satellites going by, etc.
Okay. So you can track satellites, and this again, maybe some distinction between a stargazing app is that it's not just what's up there right now, but maybe you could go forward. I want to see what's going to be available on the evening of the 26th, or in the
future
past.
and past, yes. And you can change your geographic location. That might be trickier on your phone, but if you want to observe from Ecuador, just plug it in.
And right, you mean even if you're not in Ecuador, you can ask it to show you Ecuador.
Simulate what's in the sky.
Right.
For those settings.
All right.
I recommend it as a lifelong stargazer. It's certainly the best and very accessible. Works on all kinds of platforms. Students love it.
Okay, and that's why you call it a planetarium rather than just a stargazer, because it's sort of going beyond that.
Jargon.
Right. Okay, well that's good. And that one is called again. What was the name of it?
Stellarium, Stellarium,
Stellarium.
Stellarium. Yes,
Stellarium. Okay,
right. And the links I provided will
sure.
show that.
We'll have those in the show notes. Thank you. So Robert, what's the third tool that you like to share with us?
I thought you'd never ask, but here it is. Um, Again, being a lifelong stargazer, I'm concerned with how the sky looks, not just meteorologically, cloudy, what have you, aurora, but even in Marin County, you might have light pollution from nearby cities and towns. And so a device that's proven very handy is this guy called the Sky Quality Meter. And the Sky Quality Meter allows you to measure the brightness where it's toward which it's aimed, and try to wake it up. So we see a number in an indoor lighted room. We're getting 10.85 units. What are these units? Well, it gets a little wonky, but bear with me. It's a simple little box, 9-volt battery. Not much to it. It's just a light meter, but it's delivering that information in a astronomically useful form, that is magnitudes per square arc second. You might think that's like furlongs per fortnight, kind of analogous, but it's brightness over a tiny patch of the sky. Why does that matter? Because we can put it into a numerical scale. The best dark sky you've ever seen, I've ever seen, registers at about 22 of these units, magnitudes per square arc second. And here inside a bright room, 10.5 kind of number. Urban locations, you're
So
probably
it's the idea that
seeing,
you want the number to be as small as possible?
yeah, magnitude's a funny thing. It goes backward. We can thank Ptolemy and friends for introducing that in their old star atlases.
Right.
The way I explain it to students is basically the first bunch of stars you see after sunset are the first magnitude stars. Second bunch of stars you see after that would be the second magnitude stars. Can you guess where this is going? So unaided human eyesight, maybe sixth magnitude under good conditions, young eyes. But here we're seeing the equivalent of 10th magnitude stars on the ceiling per unit area. And in a truly dark sky, like you might find up in the hills, you'll get down to 22nd magnitude, very faint. Hubble telescope, long exposure, can push it to 30th magnitude. You can imagine how faint that is.
Okay. And so why is this device useful? What does it do, or what does it allow you to do or not do?
Right. What does it do for Kevin, in other words? Basically, it lets you, at a glance, assess what can I do with tonight's sky? Is it good, bad, or ugly? And if it's good, great. You know, you can deal with long exposures, try to go deep, see those galaxies. If it's bad because of cloud or smoke or urban light pollution, then maybe you won't waste time trying to go long, as it were. And if it's ugly because of weather or fire smoke, something you've probably experienced too, it'll wake you up to that fact. And equally importantly, one more point is that you can monitor what's happening in your neighborhood over years of time if you're patient. Is that subdivision really throwing a lot of extra light in the sky? I can no longer see the Big Dipper, for example.
So
Quantifies it.
Are you saying that this sort of detects whether it's good or bad beyond what I can see? I mean, if I walk out and I look up, but shouldn't I be able to see whether there's smoke in the sky or hazy, or if it's a hazier or clearer night? Shouldn't I just be able to see that with my eyes?
At night, if you're seeing the effect of smoke, it's really bad.
Right.
When it's a thinner layer, some stars will burn through. But I believe a lot of your viewers, listeners are interested in the night sky and are aware of light pollution. So those of us in the biz, if you will, can monitor light pollution from all locations, compile information, watch the trends, and kind of try to keep tabs on what's happening due to lighting developments. The introduction of LED lights, especially those harsh blue LEDs, has really added a lot of brightness to the night sky in a lot of areas. Maybe you've seen it.
And so it may not be noticeable to you. That's why you want to use a device to measure it.
Right. It quantifies what's happening. It's a calibrated, testable record that you can share.
But right. So it's, if you're interested in tracking it, that's what it's for. But it may not really affect your telescope beyond what you can see with your own eyes.
Ever been to a star party?
No.
Other than Hollywood, of course. But a star party is where like-minded astronomers of all stripes, amateurs, professionals, get together with their telescopes and share the view, compare notes. It's like car collectors. They want to show what's good and bad. Generally, you'll find several of these high quality meters in the bunch, and people, kind of assessing quality of conditions. Can I see that dim nebula or galaxy tonight? Well, here near Pacifica, sky's so darn bright, I can't pick up that due to low contrast, bright sky, dim object.
So you might say it's not worth looking because I can tell from the quantified measurement that I'm not going to be able to see that.
Right. I'll stick to the bright stars and planets that night.
I see. What would your fourth tool be?
All right. Now, I hope you can bear with me and your listener viewers too. It's a little wonky. Deals with spectroscopy. And it's this cute little device known as a lighting passport. AlliedScientific.pro. And curiously, these last two devices are both Canadian manufacture, different outfits, but they're really into it in Canada, I guess. This is a phone app driven spectrograph. Does Kevin know what a spectrograph might be?
Well, sure. It's going to tell you what the elements are, the spectral lines due to the glow of the different elements, which can help you determine what the composition of the source is.
Absolutely.
And so is this a way of putting it on the end of your telescope so you can spectrograph whatever image you have, whatever star you're pointed at?
Essentially, yes, although not necessarily with a telescope. Certainly telescopes use that. James Webb is, of course, collecting spectra of exoplanet atmospheres these days. Amazing stuff. But for some people not as familiar, almost everyone's seen rainbow glasses like these. Put them on, you see the rainbow colors all over. That's what this device is doing, except it's quantifying the signal. That is, it allows you to get a color versus intensity map of whatever light source is out there. Now, without firing up my phone app, I can't show you that. It is in the slide set I'll share with you, the PDF. But essentially, it'll show you where in the spectrum the colors of that lamp are emerging. So as you may know, the old incandescent bulb is hot to the touch. Why? Because it's putting out a lot of infrared light out, as well as a bunch of red visible light. LEDs nowadays can put out visible light, but the higher color temperature ones, come back to that in a moment, emit a great deal of near UV, near ultraviolet light. And it's that near ultraviolet light that scatters like crazy, gets into the atmosphere, brightens up the sky. Also risks ruining part of your retina because those photons are sufficiently high energy that they're starting to overwhelm your biochemical reactions. In the language of chemistry, we're talking about fractions of an electron volt. What the heck is an electron volt? Well, it's the energy to move an electron across 1 volt of voltage difference.
So going back to the device is meant, again, I thought it was telescope, but you're saying it's a device that you use to get the color temperature of different light sources, whatever they might be, whether it's, and again, is this, what do you do with this information?
Right.
How is this helpful or beneficial?
Same idea as with the sky quality meter, except now we're getting the color dimension. And among the reports that the device will read out are the so-called CIE color map parameters. As an artist, you probably know about the color atlases that have been published over decades of time. They're the basis for selecting pigments and mixing colors. There's a huge artistic background to all that. Be happy to later tell you all about that too. But every light bulb you can pick up these days, right? Here's a CFL type. On the side panel, we'll give you something called the color temperature. And in this case, it's reporting it as warm, or 5,700 degrees Kelvin, although it is possible to get those so-called cool white hot LEDs. That is 5,000 and 6,000 degrees Kelvin. And it's those hotter ones that emit so much more blue light and have issues associated with them. There are medical studies I can share with you sometime about impacts of these things. So uses, well, again, being a veteran sky watcher, I notice how the brightness of the sky is changing, how the color is changing toward the blue due to the introduction of all these energy-saving LEDs at overwhelming intensities that might not be truly necessary for safety, going that bright and intense. And so it's part of a worldwide effort to understand what's going on with light pollution and its many impacts on flora, fauna, and the rest of us.
Okay. And would there also be a benefit that if you wanted to measure the color of the lights in your house or the lamps in your house and you didn't know what they were, you could use this to do it? Is there an optimal temperature, color temperature that you recommend?
Well, many of the medical papers refer to as lower temperature as being better in the respect. Those photons, particles of light, are the lowest energy. They will have least effect. If you sit out in the sun too long, why do you tan? Because of the UV rays leaking through. They're damaging your skin slowly, tanning it or burning it, depending. Whereas the redder light, sunset and so on, doesn't have that effect. In terms of your lights in your house, first of all, just look at what color is it? Is it kind of yellow to the view, or does it have a strong blue aspect to it? And those bluer ones will be the hotter LEDs if you've changed over to those things. If you still have some tungsten around, those will definitely look more on the orange side of things.
So is there a color temperature that you recommend?
Well, I'm partial to the coolest ones, 2,700 Kelvin. So here's a hot LED in a little pen light, and you can detect the very prominent blue.
So if you use your little device there, what is the temperature of that one?
This would be a 5,000 Kelvin type device.
I thought you said it was 27. No, you said
27 was my preference, 2,700 Kelvin. This little light bulb, blue LED, closer to 5,000 Kelvin.
I see.
So low temperature.
So what's a tungsten light bulb?
Oh, well, remember Thomas Edison?
No. I mean, what's the temperature? What's the temperature?
Oh, temperature that.
Color temperature.
Gosh, it's like 600 Kelvin. So it's mainly an infrared source, which is why it's hot.
Right.
It leaks a little bit of visible light as a side benefit. That's why it's so inefficient. You're burning a lot.
Do they make LEDs that are 2,700?
Yes, absolutely. Those are the so-called warm LEDs.
Okay. So
next time you're at the big box or wherever, you can look at the side of the package, whatever shape, and you'll see color temperature or light appearance with these temperatures plastered on there somewhere.
I don't recall seeing an LED that low at 2,700.
They do exist. Ask your friends.
Ask your friends. Okay. So so that might be one thing for people is if you're shopping for LED light bulbs, look for something at the lower end that it might be healthier.
Well, less annoying. Some of us are photophobes, maybe why I look at the night sky. but the harsh blue color of these hot LEDs I find troublesome, and there's a mounting medical evidence to that effect worldwide as well.
Yeah. So
It's the blue screen problem, right?
mhm,
Don't use your screen at night if you don't want insomnia.
right. Or change the temperature on it.
Yes.
You can do that at any time, not just at night.
Mhm.
And have you changed the color of your computer monitor?
Yes, I do that to go with the redder screen. There is an advantage to the blue light. It's great for task lighting. If you're trying to solder those tiny wires in the shop, you might need a little bit extra blue light for visual resolution. Because again, your eye resolution does vary with wavelength also, well-known optical principle. So the blue light is great for that fine detail work.
Mm-hmm. Okay.
But it should be focused and used where needed, like
Okay.
all light.
But a better solution is have you focused bluish light, whereas a ambient warm yellow light.
I find it more comfortable. Lots of people do. It's less glaring and harsh for many of us. Some people might like it. It's a bit of taste there, but it's the energy in the light itself that really matters.
Right. Okay. Well, thank you. That was really great.
Thank you.
And I don't know if you said the actual name of that last device. What was it called?
Right. It's known as the lighting passport. It's another one of those little, $1,000 devices,
Uh-huh.
but it does generate detailed quantitative spectra of what it's aimed at using a phone app. And you'll see in the slide set, the PDF, some examples of the measurement and the color indices. And this may be of interest to your art friends. A device that delivers details about color indices, that's what a lot of them are into. You could refill your paintbrush with ink if you like, reference, or measure it.
Mm-hmm. Okay. So for those who are listening, it's a little kind of square device about the size of a playing card. And
Right.
there was the previous one too. They're a little pocketable, battery powered.
Palm size, shirt size.
Right. Well, thank you, Robert. So I know you have a mission for light pollution. Tell us a little bit more about that and where people can go if they wanted to learn more.
Right. I did include in the slideshow a link to the light pollution map for the world and focused on the US. You can see, you've all seen the image of US at night, world at night, showing cities primarily. And the geographers love it because they can map population trends, changes over time. But for an observer trying to get those faint galaxies, it shows you where in Nevada you have to travel to find a dark sky anymore. So I've been involved with observing since decades ago and have noticed how the change of our urban lighting especially has resulted in an ever increasing bright sky. So I've joined the International Dark Sky Association years ago. Their website is darksky.org, simple, darksky.org. And they advocate for more prudent uses of light, the energy we use in lighting, the health impacts, not just to humans, but animals and insects, and you name it. It has its effect, not least of which is, of course, would be burning fossil fuels to light up the sky. Is that a sign of a prudent civilization? So it's been a passion, along with studies of global astronomy, archaeoastronomy particularly, and knowing your Asia interests. I have published on a couple of sites in, for example, Cambodia and northern China. If we have a minute, I'd be happy to tell you about those.
What's special about those sites?
Well, they're fairly ancient. The Cambodian site Angkor Wat, of course, appears on the national flag, prominent multi-towered structure built in the 11th century by the then emperor, who became emperor because he and his buddies set up the first wide-scale irrigation system to handle monsoon rains.
Mm-hmm.
Maybe something the Pakistan folks should have learned. But by doing that, controlling water, managing crops, they became wildly successful. And even Chinese visitors report in their annals that the Cambodians, Khmer, literally, were so clever they could predict eclipses and phenomena far better than the Chinese could at that early time. And
so, I'm a little confused. So is this
sure.
Is this like you're saying these were historical astronomy sites for astronomy? They're nothing to do with the night sky today, right?
Well, they're called temples,
right?
Like the Taj Mahal.
Okay,
a lot of
architectural
work.
Sure.
Large scale, we're talking kilometers of development,
right.
surrounded by irrigation controls, canals and ponds.
Sure.
And the temple itself is arranged geometrically in such a way that I could figure out what time of the year it is by watching sunrise and sunset, kind of the classic Stonehenge model.
Sure.
And published a paper a while ago about what the geometry, the triangulation would allow you to do for sun and moon tracking. And of course, that was a sign of civilization, high civilization in the Middle Age period to be able to do that. And their architecture encodes all that.
Okay, great. So I have a question about the night sky. If you could travel anywhere, with the caveat that you want to stay at a hotel at night, what is the best places in the world? Where is the best night sky or the clearest skies in the world on land where you could stay in a hotel?
Right. Gosh, there are fortunately a number of choices. The Atacama Desert in Chile comes to mind.
And there's a hotel there.
Well, probably in Agua Prieta, there's lodging to be had. Yes, that's the nearest town, which is itself at about 4,000 meters elevation. But up at 5,000 meters, astronomers have installed a bunch of modern telescopes, including something called ALMA. You may have seen radio astronomy images of amazing detail coming out of there too. So that would be one option. Closer to home, certainly in the Sierras, there are still good places. But I have a couple of favorites, of course, having lived in Colorado, some of the high points there. You're within driving distance of lodging, but you can still access good dark sky. And a surprising point is good old Nova Scotia. The north side of that island is fabulously dark. So if you're planning to head that way, consider it.
Is there an area that has sort of the world record currently for the clearest, darkest sky on the planet?
I think Hawaii, the Big Island summit, of course, comes close. Yep.
Right.
That's at 13,000+ feet. And it's also why those telescopes were developed there.
Right. So it's really a matter of altitude, really.
Yeah. And I think I could arrange a pass if you want to visit there sometime.
Right. So in short, if you want to have the darker sky, you have to go higher.
High helps, right? Because water vapor tends to settle near the ocean.
That's why I was surprised by Nova Scotia. Nova Scotia is not that high.
It's also stability. So Florida is overlighted, but they have a very laminar, layered atmosphere. So the starlight can come through without wavering much. I should say the north end of Prince Edward Island, although a lot of Nova Scotia similarly is pretty undeveloped in that sense.
Let's see. Okay.
You have that maritime still air at times that can help the starlight come through undisturbed.
Right. Okay. All righty. Well, thank you. I appreciate
thank you.
I am taking time to let us in on this world of astronomical viewing and astronomy tools. So thank you for sharing those with us.
You're welcome.
We'll have links for people on wanting to know more about the light pollution stuff that you're tracking.
Or any facet of astronomy. I'm happy to answer questions at my email there from you or anyone, black holes, etc.
All righty. Well, thank you again, Robert. I appreciate it.
Thank you for the opportunity.
We're glad that you enjoyed this issue of the Cool Tools Show and Tell. Just want to remind you that we have some other coolish material on our YouTube channel here. Please subscribe, comment, like. In addition, this Cool Tools Show and Tell is also available in an Audible podcast form. You can subscribe to it wherever you subscribe to other podcasts if you just wanted to listen. And if you're listening, know that there is a visual version of this on our YouTube channel where we're actually showing the tools, and there's a little bit more of a visual component there. In addition, the same folks that put us, the Cool Tools website out, we also put out a free newsletter every week. It's very, very short. It's 1 page or less. We recommend 6 very brief items that are very succinct, easy to read. You can deal with it in a couple minutes. And every week we bring to you the 6 cool things that we have uncovered and want to share. And it's called Recommendo with 1 M, recommendo.com. You'll be able to find it there. It's free. Join 50,000 plus other subscribers every Sunday morning. You'll get it in your email box. And it's actually one of the most popular things that we produce. But we do produce other newsletters as well. One of them is called What's in Your Bag. We have one that goes out to tools and tips for your workshop. So you can get those at our website, and they're also free. And finally, I want to mention the fact that we do have a Patreon, and this podcast and this vidcast are supported by Patreon supporters. The minimum is $1 a month. And for that, you get an email to ask us anything. We'll respond and answer your question if we're able to. There are other higher levels. You can all see those at our Patreon page. And all those links are below right here. So thank you again for being a fan. And we'll keep producing stuff if you enjoy it. Thanks. Thank you to this week's patrons, which include Sari Willis, Jamie Ehrman, Brian Brooks, David Rager, Allison Pescosolio, John Hobson, Alan Lawson, Bill Patrick, Chip Riggs, and John Paul Bostor. Thank you all.